So we're prepping for the AP, getting ready for the finals. Here is a whole bunch of antiderivative problems, all right? First one says, let f prime of x be x cubed minus 6x. If f of 1 equals 11, find f of x. All right, if you pause the video, you can try it. Let's be clear that this is the coordinate point 111, and we'll need that at the end to find the c. I'm not even going to need much space for this, so I'll move these two out of the way so we have some room. I can do this right away. Add 1 to the power, divide by it. Oh, minus. Add 1 to the power, divide by it, plus c. And again, you notice I don't simplify the first step. So I plug in 11 and 1. I get 1/4 minus 3 plus c. I'll add 3. This might sound weird, the way I just did this, but it sure works quickly to get that c as 13 3/4. You notice I didn't force together the fourth. You notice I don't force together the fourth and the 3 at this point. Do what's easy, especially if you're preparing for the AP, right? There's no reason you can't do it this way. All I got to do now is I can move this stuff aside. I know c is 13 3/4, so let's leave that so I can see it. And then I get what? F of x equals 1/4 x to the 4th minus 3x squared plus 13 3/4. And there is your first problem. All right? Slide this down out of the way. I can bring 2 back in. All right, so everybody, first thing I want you to notice about problem 2 is it has y in it. So this is a differential equation. This is not, this is not going to be one where you can just integrate like the first one, where it was all in terms of x, right? And dx is implied. This one's different. And again, I'll try to move this up out of the way. We'll come back to the last one, the trick one. So the first thing you got to do is separate variables. And so what I'll do is I'll multiply by dx and 3y squared. And our first step has to look like this. And then on the AP, if you don't do this, you get no credit. On my final, if you don't do this, you get no credit. If you don't separate, there's no hope. Now it's just integrating both sides, right? The integration here now is I'll integrate 3y squared over 3, which becomes 3y cubed, right? Add 1. My bad. I kind of started writing it wrong. Equals, and now here I'll do that. And somewhere, I don't care which side, you got to stick a c. And again, I don't simplify first, personally. I just don't take the chance that I'll screw up in my head. So now, I see this and I say, oh, okay, well, I can write this as y cubed equals negative 2 plus c, negative 2x plus c. And I know that when x is negative 1, y is 2. You guys agree? So 2 cubed equals negative 2 times negative 1 plus c. I'm going to subtract 2 because this is positive 2. So 8 minus 2, I get c is 6. All right? So I got all the steps. All I really need to do now is write this as an equation. Y cubed equals negative 2x plus 6. But that's not y. You guys agree? I probably will say solve for y. So I have to take the cube root. All right? And so y equals, and I'll write this as the cube root of negative 2x plus 6. I don't have to worry about a plus or minus, do I, with a cube root? If I had a square root or a fourth root, an even numbered root, I might have to check it against initial condition. But this time I do not. And that is the answer to this problem. All right? All right. Tell you what, let's take this one, the third one, let's cut it, let's take it to its own page. All right. So we want to find the antiderivative of that function. All right. So we're going to start this. So here we go. Everybody, one thing, and this is why I'm a slave driver, that you just got to have these completely memorized. When you look at the antiderivative up there, I hope you guys immediately thought of sine x. You maybe didn't know the sign, and you immediately thought of tangent x. Because you have these memorized so well, you think, oh, I got to go backwards for the antiderivative. You have to know those two. Because if you don't have those in your bank, this problem's literally impossible, okay? So I got that in my mind, and maybe I'll make it small but not throw it away yet. I'll put it up here, just barely readable. Now, I'm going to do the antiderivative. So I know it had to be bound because secant has undefined regions, right? So that's why it's bound. So it's continuous, so we don't have to worry about that. And then it has an initial condition. So I'll make the first step, f of t. Derivative of the antiderivative of cosine t is sine t. I check in my head that this is the derivative of this. It is. Likewise, I know this is tangent t. Derivative of tangent t is secant squared t. Perfect. Plus what? C. Awesome. Now I just got to figure out c. Well, we love radians, all right? So I get 4 equals 2 sine. Guys, you remember that this is 60 degrees? So this triangle is in the first quadrant, right? Plus c. So going back to our pre-calc days, hopefully you guys all pictured a triangle in the first quadrant with a reference angle of 60 degrees, because the first thing any math teacher does, almost all of us, is take radians to degrees. Very few people think of radians. I know that the sine of 30 is 1/2, so I plug that. That leaves square root of 3 for this one. So a little bit of work here. I got 4 equals 2 times sine of pi over 3 is square root of 3 over 2. The tangent of that is square root of 3 over 1, and I still have the plus c. I do my math. I get 4 equals, this cancels, 2 square root of 3 plus 2 is 2 square root of 3. So the constant is just annoying. Constant is 4 minus 2 square root of 3. All I have to do now is write the function f of t equals 2 sine t plus tangent t plus 4 minus 2 square root of 3. And again, using the initial condition, knowing our trig derivatives. All right? 3 antiderivative problems very easily could end up in the multiple choice on the AP. Very likely to be on the final. Keep practicing, no surrender. It's getting close.